Now, for the chain rule, the whole idea behind this is a lot like other mathematical properties or mathematical theorems. We usually have a property for the most simple case. And then we have to kind of expand our ideas for more complicated cases. And the chain rule is for, we could just think of it as complicated versions of our rules. Now, technically, this is what the chain rule says. If h of x is equal to f of g of x. Now, what is f of g of x? Do you remember the whole idea of a composite function? A function within a function? That's what the composite function is. H prime of x is going to be equal to f prime of g of x. So you just take the derivative of f, but then we have to multiply it by the derivative of g of x. So that's our rule. And I can imagine that you're looking at the rule and saying, okay, what actually is happening? Here's the idea. The simple version, and we're just going to take the power rule. If I have f of x is equal to x to the 7th power, what's f prime of x? 7x to the 6th. Alright, so I'll just say that's the simple rule. That's just the basic rule. Now, here's the chain rule. I'll say g of x is equal to x squared plus 2 to the 4th power. Now, in this case, if I were to cover up this and just say, all right, everything inside the parentheses is being raised to the 4th power, correct? And if it was just nice and simple, I could just take 4 times that stuff to the 4 minus 1 power. And that's basically what we're going to do. We're going to say g prime of x is equal to 4 times the x squared plus 2 to the 3rd power. But since this is not x by itself, we need to take the derivative of everything that's on the inside. So this is going to be times the derivative of 2x plus 2, which is 2x. So g prime of x is going to be equal to 8x times x squared plus 2 to the 3rd power. That is a big part of it, yeah. That's your answer, and you're all good. Yes?
So where do you get the 2x from?
The 2x comes from the derivative of, this is the derivative of x squared plus 2. All the stuff that's on the inside.
Why do you multiply by both?
Why do I multiply by...
Like 4 times x.
Because it's 4 times all that stuff times that. So since you're multiplying everything, you just bring the 2x in front. and combine or you're multiplying to simplify it, to clean it up. So that's why we got 8x. Just the 4 times the 2 is the 8, and your x goes up there. Now, the biggest thing that you want to do as far as the chain rule goes is we want things in our simplest form. If I gave you this, f of x is equal to the sine of x to the 4th plus x cubed plus 2x plus 1. Is this the sine of x? No. So we can't really apply the rule to it. We could. But this idea that I have started talking about u substitution, I'm going to let u be equal to that x to the 4th plus x cubed plus 2x plus 1. And now f of x becomes the sine of u. Now, does that make sense? You just take, instead of it being the sine of x, we take the sine of a big polynomial, and we just substitute in the u. Now, if I want the derivative of f of x, what's the derivative of sine x, or the sine of anything? All right, we'll get the cosine of u. But here's the thing. U is an x. It's a function of x, so I need to multiply it by u prime. So if I could figure out what u prime is, what would be u prime here? Alright, so now I go back into this and I say this is actually going to be the cosine of x to the 4th plus x cubed plus 2x plus 1 times that 4x cubed plus 3x squared plus 2. And that's your final answer. The basic idea behind this is you're going to take something that's more complex than our simplest form, and we're going to turn it into our simplest form. But if we do that and turn it into our simplest form using u substitution, but if we do that, we have to multiply by the derivative of u. So we want to go back and we want to say, all right, we have our simplest functions. We have our simplest rules. And now we're going to change them all into chain rules. Questions before we move on? Yes?
So the chain rules is still follow our rules and just expand.
Yeah, we're going to make them unsimple now. So this allows us to take derivatives of more complex situations. All right, so the power rule. If f of x is equal to x to the n, what's f prime of x? Yep. N times x to the n minus 1. Now I'm going to say this is the simple and this is the chain rule. f of x is going to be equal to u to the n. And I guess we'll say u is a function of x. So u can be anything at all. As long as it's written like the power rule, I could take the derivative with respect to x and say it's going to be n times u to the n minus 1. But since u is an x, it's u prime. Now, let's say f of x is equal to e to the x. What's f prime of x? E to the x. It's nice and simple. If f of x was equal to e to the u, where u is some weird thing, because I guarantee you that when we're dealing with e to the something or other, we're dealing with exponential growth or decay. So this power isn't going to be just a simple power. But the nice thing is, if I say f prime of x, well, what's the derivative of e to the anything? E to the anything, but I got to multiply by u prime. So if it's not x, I got to multiply by the derivative of whatever is there, whatever expression is there. If f of x is equal to sine x, the sine of x, what's f prime of x? Yeah, the cosine of x. But if f of x is equal to the sine of u, yep, it's going to be, the derivative will be the cosine of u times u prime. And you just have to remember, if it's not just simply x or simply, and the key is, what are you taking the derivative of? We're taking the derivative, or not the derivative of, but what we're taking the derivative with respect to. We're taking the derivative with respect to x. X squared plus 2 is not x, even though there's an x in there. When that's the case, you have to use the chain rule. But if you apply this to everything, if we had f of x was equal to x squared, and I apply the chain rule to this, I say, all right, well, f prime of x is equal to, well, let's say u is equal to x, because that's the thing that's being squared. What's u prime? What's the derivative of x? 1. So remember, the generalized power rule is going to be n times u to the n minus 1 times u prime. So what would be the derivative of this? Thank you very much. 2x, right? Now times u prime. What's u prime? 1. So that just is 2x. And I think I said this earlier, but the chain rule happens every time you take a derivative. If it's just simply an x, or simply the variable you're taking the derivative with respect to, the derivative of x, the derivative of theta, the derivative of y, it's always 1. So we're always multiplying by 1, so we don't really see it. But as soon as it gets a little bit more complicated than just an x, than just another number, then all of a sudden we have to take the derivative of that chunk that is different than x. Any questions?
How do we know the difference between if it's a u or if it's an x? Would u be like a whole function, or x would just be one number?
X would just be x. Everything else we can substitute in a u for it. I'll show you. Let's say, that's a good question. F of x is equal to the sine of x squared plus 3. Is that the sine of x? No. It's not the sine of x. So we have to use the chain rule. Which means, all right, I can take the derivative of the sine function. What's the derivative of the sine function? Okay, so f prime of x is going to be equal to the cosine of that x squared plus 3. Now, this is my u, the x squared plus 3. U prime is 2x. So I multiply by 2x. Because it's that composite function. The first function is the cosine. The inside function is x squared plus 3. So you have a composite function in that case. Now, let's say we have f of x is equal to the tangent of, let's see, 5x. This, you can leave that as your final answer, or you can leave this one, you can move that out front. Just remember, once you get the cosine of an angle, you can't touch the angle. So don't multiply the 2x and don't distribute that into there. Don't fall into that trap. All right, what's the derivative of the tangent? Secant squared. So I need f prime of x is going to be the secant squared of f of x. Now, we ask our question, is that x? No. So what do we have to do? Chain rule. Take its derivative. What's the derivative of 5x? 5. So I'm going to multiply it by 5. And that's your chain rule. And then we can clean it up. 5 times the secant squared of 5x. So whenever we're taking a derivative, you always ask yourself, because our basic rules were always for the derivative of x, or sine x, cosine x, tangent x. If it's something different, chain rule has to come into play. Yeah, we should probably put that in there. Now, I want you to try this one. F of x is equal to the sine of the cosine of 2x. So I'll give you a, well, go step by step. Work from the outside in. That's what you want to do. What do you think?
Would it be cosine of negative sine of 2x multiplied by 2?
No. But you're kind of on the right track. Ish. Okay, Sean, let's see.
Would it be cosine of 2x times negative sine of 2?
No. But you're close.
Would it be cosine times negative sine 2x
You're close.
The cosine of the cosine of 2x times the negative sine of 2x times 2.
Yes. What?
Oh, I understand.
All right, f prime of x. You're absolutely 100% correct. Start at the outside. It's just the sine function, isn't it? What's the derivative of the sine? Cosine. So what you'll do is you write the cosine, and then you write what the cosine was of. It's the cosine of 2x. Now, you cover up the original cosine, and you say, all right, is that x? Chain rule. So what's the derivative of the cosine? So it would be negative sine of 2x. And then you cover up the negative sign and you say, is this x? So we got to multiply by the derivative of 2x, which is 2.
That's not x either.
Just go. It ends there. I understand exactly what you're saying. You're saying that's not x. So if you take the derivative of this, what's the derivative of 2? 0. Psh, everything goes away. For some strange reason that I don't know, it doesn't happen like that. You just keep taking the derivatives until you can't take another derivative. And you don't take a derivative to make it 0 and make the whole thing 0. Because obviously that's not the case. I mean, if you were to graph this, I don't know what the graph would look like. I don't care what the graphs look like. But it's going to be a graph, and it's not going to be a horizontal line at 0. So we're going to be getting different values. So if we put a 0 in there, it's going to wipe the whole thing out, and we're out of luck. It would make calculus useless. So to clean it up, all we have to do is take the negative, that's negative 1, negative 2, put negative 2 out front, because you want to put your variables and all your stuff that isn't a trig function at all out front. And there's a negative here, and there's a 2 there. So negative, it's a positive times negative times positive. So it's going to be negative. There's a 2, and then I'm doing the cosine of 2x times the sine of 2x. Now, I don't care if you put the multiplication signs in there, because it's easier to see, it's easier to read. I used to do this a lot. The negative popped out to the front because I had negative. It's positive. This answer's positive. This factor's positive. That one's negative. This one's positive. So if I multiply positive times negative, I get a negative. Times a positive, it's a negative. So I put the negative out front, just to clean it up, to make it more purty. I used to do this all the time. I was a parentheses abuser. I used to do that just to make sure everything was separated. And that's what you want to do. Whatever way you want to be able to separate it, separate it. Because you want to make sure that this cosine of the cosine, because that's weird. You didn't have to do a lot of that last year, I can imagine. Cosine of a cosine. But you can keep doing it and keep going on forever and ever and ever and ever and ever if you need to. I gave a bonus problem a couple years ago. It was sine of the cosine of the tangent of the sine of 3x. And no, people got it right. It was like that long, but people did get it right. Because you take the sine, then you take the derivative of the cosine, then you take the derivative of the tangent, then you take the derivative of the sine, and then you take the derivative of 3x, and you multiply it all together. Yeah, go ahead, try it. What the heck? If you can do this, There ain't no chain rule out there that's going to hurt you. The sine of the cosine of the tangent of the sine of 3x. Now, y in whatever supreme being or lack thereof you believe in. See, I got to cover all my bases since it's public school. Why would someone build this function? No one knows. Just to make math students mad. That's the only reason why you get a function like this. It's just to make math students mad. This one you need a lot of space on. I'll move that over because I think I might need that much room. And don't clean it up. You don't have to clean it up. Just make sure that your factors, if you did, that's fine. But just make sure that your factors are separate.
Teachers and students, pardon the interruption. With the following students, please report to B17 for Iowa makeup.
This is going to go great on
Karen
my
Coleman,
video that I'm making.
Shaka Ora, Jonathan Pegulagan,
Oh, I thought it was me.
Adele Palespas, Rojob Palespas, Giuliano Hankins, Daria Persina, Yana Pacino, John Perkins, Xavier Petway, Abigail Pierce, Dominic
Rayola?
Jake Price,
Sorry.
George Reyes, Veronica Reyes, Clevia Rizuki, Taryn Renshaw, Leah Rivers, Jessica Bruce, Rosa Savage.
This is the part of the video that you fast forward through.
Samir, Amelia Serkis, Jillian Shell, Sarah Schultz, Badi Shada, Millard Shafo, Marvin Shamani, Nicholas Shamu, Timothy Shamu, Christina Shango. Please report to B17
Which one?
at this time for Iowa makeup. Thank you.
I can give you the sheet when I'm done with it. All right, not a problem. All right, let's see. Now, this is one of those things where covering up stuff is good. What's the first function we got to take the derivative of? Sine. What's the derivative of that? All right, it's going to be, and I'm going to put this stuff in brackets because I just need to. It's going to be the cosine, and then you just write everything else. Cosine, tangent, sine, 3x. All right, now, I took care of that. Now I got to take care of the cosine. What's the derivative of the cosine? Negative sine of tangent sine 3x. Bam, bam, bam. Now I took care of that cosine. Now I got to take care of this. The tangent. What's the derivative of the tangent? Secant squared times the sine of 3x times. Now, what's the derivative of the sine? And so I took care of the sine and then times 3. That's it. So that's as nuts as it gets. Usually our chain rule is going to be a little bit easier than that. However, that's a pretty. I mean, if you can do something like that and understand that you start from left to right. You look at the function. If it's not the really easy rule, it's going to end up being a chain rule. And just remember, chain rule applies to every derivative from now on. From now on, the chain rule is with every derivative. You don't have to write it if it's like 2x to the third power. That would be 6x squared. You don't have to write times 1. You don't have to do that. We understand that if it's just a simple x, we're good to go. If it's not just a simple x, chain rule. Even though the chain rule applies to every derivative, because every derivative has the chain rule in it. I did. All right, let me stop the video.